record that so that it will be helpful for you in the future. So just what exactly we have done is like I have initially first thing is like CAD model is built in CATIA, like just a cylinder, right? It is. So we have built it in CATIA. Then we are importing that into directly the model has
You did
been.
not build it in Abacus, sir.
No, we can do it in here also. Okay, then that would be better. So the simple thing we can build. When it comes to the complex thing, it will be very difficult. So as a part,
Yes,
I'll
sir,
take
yes,
it
sir.
as a solid, 3D deformable. Okay, and solid, I'm taking
Solid
as revolution,
vision.
and actual size I'll put as 1.
Why we are taking revolution, sir?
Because I'm just generating as a square and then I'm doing it as revolvation. What happens like if I take circle and extrude it, it will be in
Yes, sir.
two different surfaces when we extrude. So when we revolve it, we'll have one surface, outer surface will be 1. So that is only just a simple thing.
Okay.
So I have
Okay,
taken
sir.
that, and as you know, the dimension of this 0.0. 1 second, I'll just open the. What are the dimensions? Do you remember the dimensions?
Yes, sir.
Yeah, can you tell me the
Diameter
dimension?
is 0.0391.
0.0391, right?
1, sir.
So
Yes, sir.
divide by 2. So it is 0.195. So I'll just copy that and paste over here. So you can see that it's approximately. And about the height, it is 0.08.
0.08.
Okay, now our geometry has been done. Okay, revolve, you need to give an angle that is 360. Just provide it. That's it, your geometry is generated. First the part is generated. After that, properties, you add your properties. Density, elasticity will be your porous elasticity, and plasticity will be clay plasticity, and go for permeability. Yes. So here for density, it
Yes.
is how much it was, 173.06.
Sir, here you are converted in kg per meter cube or
Kg per meter cube. All the data, all the units are in meters.
yes, sir, yes, sir.
Okay, so it is kg per meter cube, and your porous elasticity bulk modulus as per the datas. Your bulk modulus and dimension 0.1293 is a lambda. Okay. What all is asked here? Poisson's ratio is 0.3. Ultimate tensile limit we consider it as 0, and the bulk modulus is a value is something. I hope this would be the value. I'm not remembering the value. Okay. I'll cross check that otherwise. So bulk modulus, your plastic modulus layer stress ratio and initial yield surface size we consider for first case would be like 200, right? So I'm
Yes, sir.
considering for 100 would be your first elastic surface 100 kilonewton kilopascal, that will be like
100 is
okay 10 raised to 5. So stress ratio is already given. The stress ratio is 1.344.
1.34.
Okay, and logistic plastic module K value 0.0322. Let me check on the other. Yeah, 0.129 will be your bulk modulus,
Yes, sir.
and stress ratio 1.344. And this is for the last case. And wet surface sizing and flow rate will be 1 1, considered as 1 1. Okay, this is that. And when it comes to porous elasticity, 0.0322. Okay, so these are the values of the material, and the permeability K value will be is 0.0332, and void ratio is depending on the particular case.
Sir,
For
I
this
think,
case, yes,
sir, in paper, I think meter per second is permeability value, no, sir, 5 into 10 raised to minus 9.
this K you're saying, right? Permeability, which you're this one.
Which you have sent file, no, sir, I think you have done 0.0322 only.
Okay, sorry, this value, right? Okay,
Permeability, sir.
yeah, and the void ratios is 1.258.
1.28.
So this is for the specific weight of liquid, we consider 9810.
Yes, sir.
Now each material data is added. For that section, we are considering the same as a material section
Yes,
1, and we are assigning that particular to the set. So this is now properties assigned to the geometry. Moving to the next
yes, sir.
is to generate the step. So first step is considered as initial step. Okay, and the second step will be considered as confining pressure.
Yes,
Okay, so that will be geostatic, sorry,
sir.
yeah, geostatic. So continue. So here large displacement should be on and automatic. And the automatic, for this you need not to take 8,000 seconds, just give
Yes,
as
sir.
1 and 1. Okay, and when it comes to here, same, no changes at all the default values for geostatic. And the
Yes, sir.
next step would be like
Yeah.
consider, one second. Okay, next step is your create a new shearing.
Yes, sir.
For that we consider as a soil.
Nice.
Here you need to consider increment as, sorry, here the time period has 8,000
8.
seconds. Okay, and include this. Okay, no issue. Here I'll take it as 8,000 itself. minimum as 0.08, no issue. I'll reduce this to
Yes, sir.
only 10 number of increments. I don't want much
How
of the
to
increments, okay?
change maximum number of increments, sir, depending on this soil problems?
It will
How?
be like for certain, what to say, number of elements. If your
Yes,
number
sir.
of elements are more, so you require
Yes,
the
sir.
increments as more. Okay. So on
Okay.
that basis itself, otherwise your problem will not converge. Before converging itself, your increments will change. Even your
Okay, sir.
time steps. Okay. So that is one. And maximum pore pressure change per increment is already given in the paper. They have considered
Yes, sir.
as 5 0.05 kilopascal. Okay, so that
0.05,
will
5.
be 5 itself directly. I'll add 5. Okay, and coming to other, use unsymmetric this thing, a ramp linear over steps. Yeah, this much.
So 1 minute
Yeah,
incrementation you'll take.
yeah.
For axis symmetry, you have taken maximum number of increments as 10 power 7, I think so, sir. How we will come to know that
Here maximum number of increments or maximum initial
maximum number of increments, sir? You
okay,
have taken for axis symmetry problem. First, you have sent that file, sir.
okay.
There you considered, I think, around 10 power 7, I think so, sir.
1 second.
In axis symmetry problem, sir, not in 3D.
No, it is 2D itself.
Ah, yes, sir.
10 raised to 5. It is like the number of elements are very less, okay? So any
Yes, sir.
calculations will be like within a quick turnover, you will get a solution.
How I should start, say, while doing for any other problem means if from 100 or
Just consider
50 like
100.
that.
If it is taking too large time, still your problem is not converged. You need to increase it.
Yes, sir.
Okay. If your
Okay.
problem is solving early, then reduce this number of increments. Then it will be fine.
Okay, sir.
Okay. That is number of
Here
increments in the
800
sense. Sorry.
in my increments only.
Initial
Here
increment.
increment size initial. Uh-huh.
Initial in the sense we can consider like initially 800, at 800 one increment will start.
Okay,
So
sir.
so that is
Once I take.
independent. Yeah.
Okay, sir.
Okay.
Okay, sir.
So moving further, this is done. Our increments are done. So all the 3 steps have been done. Next, moving to the loads. First thing, okay, need to go to assembly
In
first.
assembly, I think you didn't install,
Yeah,
sir.
I have not applied. So need to go for assembly one. Yes, instance need to be developed. This instance, um, make it as independent. Otherwise, it will make other.
Independent.
Yeah, independent. Apply. Okay, I'll just delete this.
Yes, sir.
So now it becomes independent. So once independent, either you can translate this to required center of point. Okay, otherwise you can just leave that. If sometimes what happens,
Yes,
the
sir.
center, your coordinate system will not count as the center. You can move that. That is what the issue only. Okay, so otherwise this is fine.
Okay, sir.
So your instant is done with independent, then move to steps. Steps has been developed. Then for loading first I'll consider as confining pressure. For confining pressure, consider pressure. Continue. Select the surface and the top.
Yes, sir.
That will be your first pressure as 200
200
kilopascal.
kilopascals.
Yes. Okay. And then the loading is done. Boundary condition, initial boundary condition, displacement and rotation. Continue. Select the base. Here you need to give all the three direction because it is a 3D. You
Sir,
need to,
1 minute, sir.
yeah.
For this one boundary condition base, my sir, I showed today this file. He asked to do all directions.
Yeah, that is
Is
what
that
we have
possible?
done. All directions we have done, right?
Not,
X, Y,
no,
Z.
sir, not this one. Boundary condition. You are on your under reactions also. He said to take that also, sir.
I didn't got.
I did not get graphs correctly, sir. So he
No, as you showed this file, the boundary conditions are
yes,
considered all the three direction X, Y, Z. U1, U2, U3 are
he
nothing but.
said to take.
Yeah, yeah. Tell me. He said to.
Okay, sir. Okay, sir. Okay, sir. It is correct only. I
Yeah.
think next one.
Okay. So this is considered boundary condition is done, and next is one second. One more thing we need to consider. Once the boundary condition is done, what all considered? Okay, one is loading. First is okay, pore pressure. That will be considered as
And another
and
void ratios.
yes.
Movement.
So all the three. First thing for initial condition, oh sorry, for confining pressure, pore pressure.
Yes, sir.
No, one second. Here it should sometimes it will get changed. Now this one is for pore pressure is for confining pressure.
Pressure.
Third boundary condition would be for shear stress considering. Okay. So for confining pressure, pore pressure considering at the top surface as zero.
Zero, sir.
Yeah, zero value because you are considering as a drainage layer, top layer as zero only.
Yes.
Okay, so this is done. And the second one is for shearing displacement as a top surface will have a displacement of minus 0.032 as it is
Sir,
said.
here you are given 0.032, sir. Which file you have sent for me now, sir?
0.04, that is what I want to say you now. For
Yes, sir.
0.03, your entire result is not matching at all. Okay.
Okay, sir.
So when you give 0.04 only, your results are
Yes.
exactly matching with the paper. I don't know
Okay,
why
sir.
they might have considered 0.32. I don't know. As I'm checked with the all the results 0.03, 0.04, 0.056, 52, all I have checked.
Okay,
So it is matching with 0.4.2 itself. Okay. So that you
okay,
can
sir.
make a change that only the upper displacement it will get
Okay,
displaced
sir.
for certain thing. Okay. So this is one. So all the three
Okay.
boundaries are over. Yes. Then comes your predefined field for
Predefined.
yeah for initial condition geostatic pressure.
Yes,
What
sir.
okay? So for here I considered zero. The first is considered as your wide ratio. That
Okay.
is it is given same.
So void ratio we can consider even lesser values also, sir.
No. That is for
Or we
the
should take,
third condition. It is already wide ratio they have provided right in the paper.
no, sir. For this analysis we can change or then it will get aborted or errors, sir.
It will get some other values. If you change that, the values will not match. The wide ratio itself
Okay, sir.
gives you the predefined thing. Okay, so that
Okay,
is
sir.
one thing. This value is the wide ratio is for the calculated from the paper itself. This is for the third condition.
Yes, sir.
Okay,
Yes, sir.
so that is what. So the wide ratio for initial other wide ratio. So consider all the surfaces, all the four surfaces.
I should consider
Okay. So if you leave this, your result will not be, or you will get an error.
matching.
No, you will get an
Yes.
error. Your simulation will not run.
Okay,
Okay.
sir.
Okay. So this is one. And next is giving a predefined field for shearing. Sorry.
Yes, sir.
Confining pressure.
Defining other
No, initial itself,
initial.
geostatic pressure for whole body. Initially at 2000 sorry 200 kilopascal
Kilopascal.
at zero point zero 0.08 at the base, considering at this point your thing. And next time I need
0.08.
yes
I think point zero 0.08, sir.
sorry.
You have given vertical coordinate. Sir.
Okay. And the other will be 0 and this will be considering lateral coefficient as one as same as this, so it will be done. So all your loads boundary condition has been done. Loads boundary condition as given. Next, moving towards mesh. So it is just simple. Assign the element. Consider element type as they have said in the paper.
Yes.
C3D20 RP.
Yes, sir.
Okay. For
Reduced
that,
integration.
yes, reduce integrity. For that, go for porous fluid stress.
Fluid state.
Quadratic elements. So you can see C3D20 20 bit.
RP.
That is second order. Linear will be
Okay,
first
sir.
order.
Yes,
Quadratic
sir.
is the second order. So that is assigned seeding. Here it comes with the number of elements. So I'll
Sir,
consider
it will give 0.005, sir.
your number of elements will be more. So just I'll show because however we are not running this right.
Okay.
0.05.
I
Okay.
can take, no, sir. Sir, my sir said to take 0.005 and try once.
No,
I was
that is
not getting that, sir. Okay, sir.
these are your element size, approximate global
Yes,
element size. Okay. So when you
yes,
increase that, your number of elements will increase. I'll show that. Okay. So mesh
yes.
a very fine mesh. It is not like small. It is too fine.
Yes, sir. I was thinking to take instead of 0.01, shall I take 0.005?
No, even you take your solving time itself will increase. One day,
Yes,
one
sir.
one solution. You can imagine that if how you keep a run in the morning and you get error
I
in,
see. Yes, sir.
you can see this element size,
Yes,
right? So it will take nearly 4 days to converge and solve.
yes,
Okay, so just to show, I have shown you. So you can
yes,
increase
sir.
that and decrease that. It depends on you. So I'll just again system itself, my high end system itself is hanging.
Even my sir is not getting answers, sir. Simply he said to try
Just
zero point
try.
0.005.
Yeah, that usually will happen whether it is all depend on the conversion study. Again, you would have said that. So even I have checked with that. So by the conversion study, the values are not matching. So if you
Yes,
have
right.
just there is no change in the results. Hardly you'll get in point one or two. This thing your results will be changed. No, this is
Yes,
fine. This is fine, but it also takes a half a day to run.
to run.
Yeah. Okay. So moving to the so your mesh
Job.
is updated. Moving to the job. That's it. Give her a name. Create here. This your result is done.
Yes, sir.
Okay. So but if you give here also is fine. If you want to give
Yeah,
in a server also is fine. It all depends
yes,
again. Okay. So this is one simulation. So after results, I'll just show you the one which is already run. Because if I give this run, it will take time, I hope. Let me check.
yes, sir.
Okay. Exited with error. The wide ratio itself is not assigned. That is what. Okay. Can just go back again to the loading condition. Just delete the first one and create one more.
1.25.
One.
258.
Sorry. What is the value?
1.25.
1.25. Okay. The session will be closing now. I think we need to rejoin again once.
Okay, sir.
It's showing almost 4 minutes is left out. Same error is showing again. No issue. Let us check later. Okay. So you found everything is fine. Same similar procedure. You understood,
Yes,
right?
sir.
So I'll
Yes, sir.
open directly the result files which has already run.
Okay, sir.
I hope you have understood how to take a graphs of each, right?
Sir, I did not get graphs properly, sir. For that sake only I asked for session.
Graphs in the sense you are saying like total graph or
Numerical test from Abacus, sir.
from abacus values. Okay. So I think here results are already available. You'll see that. Okay, results are already available. Mm, Yeah, you can see that, right? So this is what you will get from their XY graphs. Take an ODB field output,
Yes.
continue. So here, the first thing we require is principal stress 1, 2. Okay,
1, 2, sir.
yes. So from here, we are considering any one point of the point. I'll just consider the top end. One point. Okay. From this, again, second is we require all the three direction
Yes, sir.
displacements. So all the five we got totally. Okay. Two times it has been selected. No issue. So first thing, go to XYZ again, go to XY plot data, select that. So initial is principal stress 1 minus principal stress 2.
Yes, sir. 2, sir.
So I'll save that as deviator stress. From there again,
Divided by
divided by 1000 to make it as kilopascal. That's it.
kilopascal.
Yeah. Once this is done, for the first graph, that is your strain versus stress.
Yes, sir.
Okay. For that, what we are doing is like taking
Combine.
combine in this L22, that is your y directional strain. That
Yes, sir.
is, you're considering this y direction, you're considering that strain values in y direction and the deviator stress in kilopascal. Just it is plotted, so you can see it is reversely plotted. So give a negative value there. Okay, just save this. XY plot. Somewhat slight change because each iteration time changes. So take these files, these values to
Yes, sir.
the graph. So you can just change that here values, this values to that. That will be updated directly. So I'll just consider go to insert, scatter, graph. This is why it is not matching.
I think axis symmetry problem graphs are only completely matching.
Yeah, it is matching with that. Why I don't know why. Again, your sir requested for this thing,
Yes, sir.
but they are similar matching. That's what I have done here. Okay, these are the results of yesterday. What I have sent, the files what I have sent for you.
Yes, sir.
These are the results of that. I have changed
So
here.
you did not send me Excel files, sir.
Okay, fine, then I'll send that. So
Yes, sir.
nothing has been changed. Okay, all the three graphs I have added here
Yes, sir.
with particularly the scalings and other things. And double clicking to this, you will get here a fill option. Always we will be keeping no fill, right?
No files, sir. Yes, sir.
Yeah, just go to picture or text file, add a picture of that, take a file of your same paper,
Yes, sir.
take a screenshot, save this as a file name. So I'll just consider this. Okay, so one. So just if you go to here, select the file, insert file name or your image.
Yes.
If you select image, that will be replaced onto the graph. That's it.
Okay, sir.
Okay. So this is what matching with your same thing. All the
Okay,
three,
sir.
when we combine all the three graphs,
Okay, sir.
so how I'll say how we have combined. I'll just consider this for example. Just what we have created. Copy this or just Control C and go to any one, make as one as a one graph as an default one. Okay, on that one press as uh, save or Control V. Okay, at that moment your file will be or your values will be generated on that. After that you can go fill picture, you can get that with particularly required size.
Okay, sir.
Okay, so that is what the simple thing. You got what we exactly are doing here. Here this graph again here. Where do I show with? Okay, clicking onto this, you can go with here minimum maximum scale values. Okay, start with the 0. No, don't go to reverse. Same thing. Okay, access values. Start with 0. Keep it 0 only. This is the old version I had. And the one more. Okay, now we can logarithmic scale value base as 0, 10. So that if that has changed. Mhm.